All right, and we're live for the first time this year. All right, so who in here wants to remind me of what it is exactly a negative exponent either implies or how we can kind of deal with the negative exponent? Square root? The negative exponent is the square root. We talked about square root exponents yesterday, but it wasn't the negative exponent one. The negative exponent, remember, pretty much implies a what? A fraction, yeah. So this is the rule. If you have a factor, not term. If you have a factor implies what operation? Multiplication or division. If you have a factor, if you want to change the sign of the exponent, whether it's positive and you want to make it negative, or usually when it's negative you want to make it positive, you just take that factor to the other side of the fraction, either from high to low or low to high. It doesn't matter where you're moving it, as long as you change the sign of the exponent. And then we had the fractional exponents, and the fractional exponents then are what in disguise? They're square roots or cube roots, or in general we just say a radical. It could be a fifth root, a 10th root. We'll see some of those today. So if you see like b to the m divided by nth power, remember we were talking about Prince's garden over here. Prince's purple tulips with purple leaves were watered by purple rain, but his purple roots grew underground, okay? And so when you see the fraction, the denominator is kind of underground. That is the root, okay? So it's going to go in the little radical crotch right there. If you were to drop that n, it would hit here and slide into that v. So that is the nth root of b to the m. And remember, these things work both ways. So if you see the nth root of b to the m, you should be able to quickly know that it's also b to the m divided by n, because this is already m divided by 1, so it stays in the numerator. The root goes into the denominator goes into the root, and vice versa. Okay? So let's quickly then redo 3a from yesterday, just so it kind of makes for a better recording. It says to simplify the following exponential expressions if it is possible to do so, not if you are able to do so. So the first thing you're going to want to do when you're simplifying expressions is if you have any radicals at all, you want to write them as fractional exponents, because we have rules for exponents that we could implement, and we probably don't think too well in terms of radicals at this point in our math career because we haven't seen a whole lot of them, and if so, maybe it's only square roots. So we have 3 times the 4th root of x squared, and we mentioned yesterday that that is different from 3 to the 4th times the square root of x squared. So your first task is really to read the problem correctly, and we know that this is the root because if you were to drop the 4, it would fall into the crotch right there, so it's not associated with the 3. The way I wrote it below is what it would look like if it were the other way. So how am I going to rewrite the 4th root of x squared as a fractional exponent? X to the, well, before 1/2 and, 2/4, okay? 2 is already in the numerator, and then the 4, which is the root, now goes in the denominator. And now you can easily see, if you didn't see before, that 2/4 simplifies to 1/2. Now, in terms of a final answer, I'll accept like 2 final answers on a free response unless I specifically tell you, like, have no negative exponents in your final answer or have no fractional exponents in your final answer. I consider 3x to the 1/2 a perfectly legitimately simplified answer. But if it's a multiple choice question, this may not be an answer choice. So pretty much it's customary that if the problem starts out in radical form, the final answer is going to be in radical form as well. But I like that. If you go on to take calculus, we kind of prefer our answers to have a coefficient, which is the number in front of the variable, and then the variable raised to some power. It's just easier to work with. So let's go ahead and put this back into radical form. It's going to be 3 times the square root of x. Okay, remember this is like still x to the first in the numerator, and then the 2, which is the root. The square root is the only one that has a root that is not visible in the little radical crotch, and it's implied to be a 2. So the square root is root 2, the only one that doesn't get written. Every other root index is going to show up. Okay, so there it is. So 3/4 root of x squared is equivalent to 3 square root of x. Now we move on to letter B. 4/5 square root of 2 to the 5th. Anyone know offhand what 2 to the 5th is in your head? 32. Yeah, you could figure it out pretty quickly, but it's 32. Is 32 a perfect square? No, it's not. Now you could probably simplify the radical, but that's not how we're going to approach this problem. You've got a 4 in the top, and you've got a factor of 2 in the bottom. we saw yesterday that you could write 4 as a power of 2. So I'm going to do two things here. I'm going to write 4 as 2 squared. And if you didn't see that inside yet, hopefully you would see it on the next line. But in the bottom, we're going to write the square root of 2 to the 5th as 2 to the what power? 5 halves, yeah. Now another kind of word on notation. Notice that if it's 5 square root of 2 to the 5th, you know that the implied operation is multiplication, right? 5 times the square root of 2. But when you write it as 2 to the 5 halves, you need something there to show that it's 5 times 2. If you don't put anything there, it looks like 52 to the 5 halves, correct? And you don't want that to be the case. So I did see some people yesterday still using this symbol for multiplication. You probably at this point in your math career want to abandon that symbol because of why? It looks like an X variable, and that could be very confusing. So typically a dot to imply multiplication when it's needed, or you could still use parentheses. But remember, in terms of parentheses, we're trying to simplify things by getting rid of parentheses. So in this case, a dot would suffice. So 5 dot, 2 to the 5 halves. And now you can see that you have factors of 2 that are divided, so you can use the rules of exponents. And remember, when you use the rule of exponents by subtracting, that result always goes in the numerator. So if I know I'm going to have a fraction on the next line, I'll go ahead and build my shelf so that I can put things on the shelf or under the shelf. It's easier to stack numerators and denominators. So what is 2 minus 5 halves? Negative 1 half. You're going to have to be working with fractions, and so you're going to have to maybe practice a little bit. But if you ever have a whole number and a fraction, it's real easy. Just take the denominator and multiply the whole number by 2 over 2 in this case. So 2 is the same as 4 halves. 4 halves minus 5 halves is negative 1 half. So we're going to have a 2 to the negative 1 half in the numerator. If you use the rule of subtraction, your result, whether it's positive or negative, always goes in the numerator, and that still leaves a 5 down there. Now notice I kind of ran out of room. No big deal. I'll just draw a vertical line, and I'll bring that to the top. We don't want to have, in this case, negative exponents in your final answer. And so let's go ahead and get rid of the negative exponent and the fractional exponent. It is a lot easier to get rid of the things in the order of how you encounter them. So if you walked up to like negative 1 half, the number, you'd be like, what's up, negative 1 half? The first thing you see is the negative. So get rid of the negative first. How would I get rid of the negative? Yes, move that factor to the bottom. And that leaves a what in the numerator? A 1. So I have 1 over 2 to the positive 1 half now times 5. Or 5 times 2 to the 1 half. And then 2 to the 1 half.
That's what I was going for originally with the 2 to the 1 half. I was just thinking that. Because the bottom one, the exponent is larger.
Right. So you could do it that way as well. You could do the subtraction in reverse. You could say 5 halves minus 2 is 1 half, but I know I'm putting it in the bottom. And I'm okay with you doing that. Okay. This is the systematic approach using the rules. Can you do these things in fewer steps? By all means, yes. But make sure that you're not skipping so many steps that I can't follow your process, because I will be grading your process. If you just have that and then the final answer, you're probably not showing enough steps. Okay? But yeah, feel free to do so. And also be mindful that the more things you try to do in your head and from one step to the next, the more likely you're going to make a careless mistake. And I do want to see your process, so just kind of get in the habit of writing it down. And now 2 to the 1 half we can write as what? Square root of 2? Yeah. So you can write it as 1 over the square root of 2 times 5. And that's fine, but remember, simplified means having less things in it. And I can get rid of the dot by convention if I just commute the order of the factors. So 1 over 5 square root of 2 looks a little bit better. So that's your final answer. And yes, there are faster ways to get to that same result. All right, any questions on B? A, B, C comes next. Let's go to C. We have the square root of x times the cube root of x. Now notice in this case, we have 2 factors of the same type. When you're simplifying, your end result should have only 1 representative factor of each type. 1 number, 1 x, 1 y, 1 a, 1 b. So I need to combine these 2 things. And here's where you can maybe say, I don't know what that is. I don't know what the square root of x times the cube root of x is. I don't work with radicals that often enough. Guess what we should do first then? We'll write the square root of x as x to the 1 half power times the cube root of x is x to the 1/3 power. Yeah. And now we're multiplying and the bases are the same. So here's where it comes 1 rung lower on the operational ladder. Multiplication turns into addition. So we got to add a half to a third. And I like to ask my waiter and waitresses in restaurants this question a lot. What is 1/2 plus 1/3? They're like, no, I was asking if you needed like more chips and salsa, not if you needed any math problems solved. I'm like, okay. But 1/2 plus 1/3 is like something that everyone should be able to do quickly in their head. What is a half plus a third? 5/6. Yeah, 5/6. Okay? Now, I do want you to force yourself to start working with things in your head. That's the pre-AP nature of this course. But if you find that you need to write down some steps to combine those, you don't do it right here underneath and then bring the problem back down here, because that interrupts the flow of the problem. You go off to the side and do it on your workbench, okay? 1/2 plus 1/3. And there's lots of ways to add fractions, right? The LCM, or the LCD, is 6, because 2 and 3 we say are co-prime. The only common factor they have is 1. That's what makes them co-prime. Then their LCM is going to be their product. So you can multiply the first one by 3 over 3, the second one by 2 over 2, add them together. But here's a real quick way to do it. This method is called or what I call the crisscross applesauce, butterfly multiply method, whatever. And it will always give you a common denominator. It won't always give you the least common denominator. But if you just start in the top left, always have to start in the top left, multiply diagonally. What's 1 times 3? 3. Then you take the sign, in this case plus, and then you take the other diagonal. What's 1 times 2? 2. And then it's all over the product of those two. 2 times 3 is 6. So you get 5/6. Again, it won't always give you the LCM in the denominator, but it will give you a common denominator. So that's 5/6. So our final answer then is x to the 5/6. And again, I'm kind of okay with that as a final answer. If it's like a short answer or free response and there's no instructions given, just says simplified, you could stop here. If the instructions say get rid of any negative exponents and any fractional exponents, you have to keep going. Or if it's a multiple choice, I probably would not have that as an answer. And so we can write that back in radical form. Is it the 5th root of x to the 6th or the 6th root of x to the 5th? Good, good. 6 is in the denominator where the roots grow, so 6 is the root, square root of x to the 5th. So there it is back in radical form. All right. Questions on that one? Crisscross applesauce. Letter D. Woo! Okay. These get interesting in a hurry. What to do first? Well, we could distribute the 2, but how are we going to distribute to the radical? Here's what I would tell you to do. First of all, notice you have 2 factors, one on the top and one on the bottom. So as you go from one line to the next, feel free to work on each factor independently. You can do a little bit here and a little bit here. The first thing that you're going to want to do when you're simplifying, if you see any kind of radicals at all, is write them as rational exponents, okay? So I have the quantity in the top, 2, and now it's going to be x to the what power? 2 over 5, the 2/5 power, excellent. And then it's still all to the second power. So I didn't distribute the 2 yet because I had the radical. And the bottom is 3 times x to the 1/5, is that right? No. Good. It's not 1/5. It's 5 over 1, so this will end up being 5 over 2. Right. Very good. Again, a lot of people might call it 1/5, not because they don't know how to do it, but because they're going too fast, right? They're not thinking. They're on autopilot. So I did a little bit in the top, a little bit in the bottom. Now I can easily contend with the superior exponent of 2 out here. So when I do that, am I going to call it 2 times 2? No. 2 times 2 is 4, and that's not what the answer is. So you want to put a little 1 here maybe. It's going to be 2 times 1, which does give you 2 squared, which does turn out to be 4, but it doesn't always work that way. The product of the exponent and the base is not always going to be the same answer. So it's 2 to the second power. I'm just going to call it that for now. Times x to the 2/5 times 2 is what? 12 over 5? Well, when you add, you need a common denominator. But when you multiply, you just multiply straight across. So that's like 2 over 1. So 2 times 2 over 5 times 1, which is 4/5. For multiplying fractions, you just multiply straight across. You do not need a common denominator. And on the bottom, I have 3x to the 5/2. Okay, so now I'll kind of draw a line, and I'll move over to the next column. 2 squared is 4, so I got 4, and the 3 is in the bottom. And now I can combine my powers of x by subtracting again. So 4/5 minus 5 halves. If you do that subtraction rule, you remember that your answer is always in the numerator. So what is 4/5 minus 5 halves? 4/5 minus 5 halves. If you can't do that in your head, again, go off to the side and do it over there. But don't do it in the flow of the problem. Now, this is a minus sign. If you want to do the crisscross applesauce method, you got to start in the top left because subtraction is not commutative. So here we go. What's 4 times 2? 8. 8 minus 5 times 5 is 25. What's 8 minus 25? Negative 17. Right. If you did it the other way, if you did 25 minus 8, you get positive 17. That's not the same. That's why you have to start in the top left. So it's negative 17 over 5 times 2 is 10. So negative 17 tenths. Kind of force yourself to try to do it in your head first and then check off to the side, or just do it in your head and be confident, okay? You want to start trying to become a little bit more agile mentally. So if you were to leave the answer like this, there's probably a better version of it. We can write that as 4/3 times x to the negative 17 tenths. And as I mentioned in calculus, this is probably the version we like because now we have a coefficient of x, the number 4/3. Then off to the side, times x to the negative 17 tenths. So this is not a bad place to stop if the instructions don't tell you otherwise. But as a multiple choice question, perhaps I won't have that as an answer. So if you want to come back up here, you have a negative exponent and a fractional exponent. Which one should we get rid of first? The negative. Now, ideally, you'll be able to just get rid of both the negative and the fraction in one step. If you're not there yet, I'll show you the baby steps. It'll be 4 over 3 x to the positive 17 tenths, bringing it down the factor, not the term, and changing the sign. And now I need one more column, 4 over 3. What is it going to be, the 17th root of x to the 10th or the 10th root of x to the 17th? Yeah, the 10th root of x to the 17th power. How many of y'all got up this morning and knew that you were going to encounter x to the 17 tenths today? Some days are just better than others. Yeah. So what I was saying about ideally doing it in one step, my hope and goal is that you can just look at x to the negative 17 tenths and realize it's 1 over the 10th root of x to the 17th, and vice versa. If you see 1 over the 10th root of x to the 17th, oh, that's x to the negative 17 tenths. Okay? But here's that intermediary step, if you need it for now. So this would also be possibly another answer choice. Either one of those could be an answer choice on a test. On the multiple choice, I probably would do this. Because on a multiple choice, I like to make you go a little bit further. But as a free response answer, perhaps that one is sufficient right there. Okay, so now I encroached upon letter E, so this is where notability is kind of nice. You can kind of shrinky-dink it down. You know, put it in a space bag and store it under your bed until you need to pull it out again for winter. All right. 4 to the 3 halves. You see any variables in there? I don't either. So this one, the instructions instead of simplify could be just evaluate. And if you had a calculator to do it, it would take all the fun out of it, okay? So 4 to the 3 halves, as we said yesterday, could be written as either 4 cubed and then to the 1/2 power, or it could be 4 to the 1/2 power and then the quantity cubed. And of course, maybe we don't even have to write it like that anymore. We could just say it's either the square root of 4 cubed, or it's going to be the square root of 4 cubed. Now, they're both correct, but in terms of like evaluating it without a calculator, which one is easier, the left or the right? The right is easier because the first thing you're doing is making the number 4 what? Smaller. Square root of 4 is 2. That's easy. And then you make it bigger. 2 cubed is 8, so that's the answer. Whereas over here, you're going to have to make the number bigger first. Now, 4 cubed is still probably within some people's comfort zone. 4 cubed is what? 64, right? And the square root of 64, y'all memorized at some point to be 8. But in general, if this number gets uncomfortably big, now you're going to have to be like taking the square root of some big number that you've never memorized. And then it's trial and error. So try to go small before you go big. Try and take a root of something before you raise it to a power. Go small before you go big. The answer is 8. So if you play any sports and your number happens to be 8, you can request coach Instead of 8, put 4 to the 3 halves on the back of your jersey and just wait for your number to be called. All right. Let's summarize then the properties of exponents. We've already gone 1 through 6. We did that yesterday. So kind of the new ones today are 7 and 8, and then 9 is a combination of both. A negative exponent is not a radical. People still get that confused. A negative exponent takes a factor, not a term, to the other side of the fraction, high to low or low to high, and it just changes the sign of the exponent, whether it's positive or negative. A fractional exponent is a root in disguise, or a radical in disguise. The root index is the denominator is the root index. The root is the denominator is the root. And then here was what I said my goal for you should be. If you see v over the m through to u to the n, you should be able to just look at it and say, oh, that's v times u to the n divided by m negative. Okay? You're bringing it to the top and getting it out of the radical in one step. Similarly, if you see vu to the negative n over m, you should be able to say, oh, that's v divided by the mth root of u to the n. Back and forth in one step. If you're not there yet, take more steps. It's better to do more steps and get it right than to take fewer steps and get it wrong. Okay, so let's start looking at some kind of guidelines for simplifying expressions. If I just say to simplify something and it's not a multiple choice, you don't really have a target. So some people don't know when to stop. What does it mean to be simplified? Well, in general, you just have fewer things in the expression. Fewer parentheses, fewer brackets, fewer exponents, fewer factors, fewer terms, all that good stuff. So this is not necessarily a flow sheet, but the first bullet point is probably what you do want to do first. If you see any radicals, any at all, rewrite them as fractional or rational exponents. That's step 1. I would discourage you from working with decimals, like 5 halves is the same as 2.5. Maybe you've grown up with a calculator in your hand, so you think in terms of decimals. It's going to be a lot easier if we work with fractions. Because if you were working with like 1/3, what is 1/3 as a decimal? 0.33333 continuous, and now it's not even as accurate. So try to work with fractions. There's usually more than one way to work a problem, right? We've just talked about that. Some of y'all can kind of skip a step. Some of y'all work from the outside in. Some of y'all like to work from the inside out. And they're both viable, right? Working from the inside out, it would be like what you would do if you were trapped inside of an onion. Working from the outside in is what you would do if you're trying to get to the inside of an onion. Okay? They both would have merit as long as you're following the rules of exponent. What does it mean to be trapped inside of an onion? Okay, I make the analogies up on the fly. So, anyway, what?
Onions have layers.
They do have layers, yeah. So I guess if you're trapped inside of an onion, you kind of have to be born there. Yeah. Anyway, a lot of tears and working your way out. The inch by inch, it's a cinch, right? Eat the elephant one bite at a time. Chew, swallow, take another bite, another tiny bite. In other words, show more steps rather than fewer steps. As you work straight down so that every line that follows is equivalent to the line that precedes it. If you need to go to another column, do so. Try not to work left to right. If you do work left to right, like it's one last step, you have to put an equal sign to equate the two expressions. And don't skip steps. It's better to show it than to leave it out. Because remember, I want to see your work. Simplify means to have fewer things in it. Okay, blah, 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 blah. Okay, we'll just go for it. So example 4 now is starting to look a little bit more like what your quiz on Wednesday will resemble. Okay? We've practiced all of these skills of exponents kind of in isolation, and now we're just going to use all of them to simplify expressions. So 14a. How many terms do you see there? One term, right? Remember, terms are separated by plus or minus signs. We have 2 distinct factors that are associated by the parentheses, your dear Aunt Sally's please part. So as you work straight down, feel free to kind of work with each factor kind of independently. You could do a little bit in one factor, a little bit in the other factor. So what could we do in the first factor? Distribute the 2. Yeah, so if you're working from the inside out, there's really nothing to do inside the parentheses. So remember, you're probably going to want to put little 1s there. If you think you're going to make a careless mistake, having 1s there can prevent you from doing that. It becomes 2 squared, a squared, b to the 6th. And if you want to call 2 squared 4, that's fine, so long as you're getting 4 by doing 2 squared and not 2 times 2. It's those numbers that students tend to mess up. So our goal is to get rid of parentheses so you don't need them anymore. On the next one, I really can't do anything yet other than rewrite the quantity that's under the radical. So it's going to be the quantity, parentheses, a b to the fifth, the entire quantity raised to what power? The 2th power? The 1/2 power, yeah. Okay, so far so good. Now, since we've gotten rid of some of the parentheses, I can combine like factors. I got a 2 squared times a 5. That's fine. Typically, you want to put any numerical factor first, and then the variables follow in alphabetical order. So what's 2 squared times 5? 20. Cool. The associative property allows us to associate those factors together. There are some other a's and b's in there, but right now we can't do anything with the other ones in the end because they're trapped inside the parentheses. So now we have to liberate them. So when I distribute the 1/2, it becomes what? A to the 1/2. Yeah, not a divided by 2, because remember there's a 1 there. And then b to the 5/2. And now you can go ahead, one more line should do it. We can combine like factors. And you don't have to even draw those lines. So in alphabetical order, the a's will go first. So we got 20a to the 2 plus 1/2. That should be easy to do in your head. 2 is 4/2, right? 4/2 plus 1/2? 5/2. And again, I prefer 5/2 over 2.5. And then we got b to the 6 plus 5/2. So here's another case where you have a whole number in a fraction. Take the denominator and multiply the whole number by that number over itself. So times 2 over 2. So you get 12/2, right? 6 is equal to 12/2. What's 12 plus 5? 17. So you get 17/2. Now someone last period asked how I came up with that. Here's how you would do it if you weren't sure. 6 plus 5/2. Put that over 1. Multiply by 2 over 2. You get 12/2 plus 5/2. And you get 17/2. So if you're still at the stage where you need to do that off to the side, that's fine. No shame in doing that, so long as you do it off to the side, and then you bring it back into the project. So this could be a final answer. I kind of like the way that looks. You have one representative factor of each type, one number, one A, and one B. But if it's a multiple choice where the instructions say get rid of any negative exponents or fractional exponents, we need to go another step further. So 20, this becomes the square root of a to the 5th times the square root of b to the 17th. Now in this case, that might not even be the multiple choice answer, because what do you know about two factors that are both square roots? There was this property that said the square root of ab is equal to the square root of a times the square root of b. And they work both directions. Same thing when you're dividing. The square root of a over b is the square root of a over the square root of b, and they work both ways. So because they're both square roots and they're factors, I could just put them underneath the same radical and call it the square root of a to the 5th, b to the 17th. So in terms of a multiple choice answer choice, I'll probably put that one if this problem were on there. I like to make you go a little bit further, maybe, on the multiple choice, manipulating it. And that's what this whole section is about, trying to get you to be a little bit more agile with manipulating these algebraic expressions. All right, any questions or comments on that one? All right, these things crescendo pretty fast. You're probably feeling the burn right now. Burn, feels so good. Whoa. Help me out. How to start, what to do. You don't want to just be plagued with indecision so that you're just sitting there staring at it. All right? Any journey of 1,000 miles begins with the first step, even if it's a step in the wrong direction. Yeah, you could distribute the 5. This would be the inside-out approach. If you're trapped in the onion, you see that you got inside the radical, you got 2u to the 5th. So if you want to take care of that, that's fine. So what would it be? Would it be 2 times 5, 10? Would it be 10? Good. And again, just FYI, that is probably one of the most common mistakes students make. They can handle the variables, but when it's a number, they just want to multiply the two numbers. 2 to the 5th, u to the 5th. And then what would you do next? Would you write down the v, or would you say, hey, since the v's are already liberated in this line, I can actually combine them? You have the option of doing that. Or you could just let that be the only step you do in that whole line. I'm going to go ahead and combine the v's. I don't want to combine the u's in this step because that step was taken up by distributing. So don't combine the u's in this step. Then I'm like, whoa, what'd you do? But since we're dividing, we just subtract, right? It's always top exponent minus bottom exponent. and the result always goes in the top. So what is negative 2 minus 3? Negative 5. Okay, so if you do the subtraction rule, it always goes in the numerator. If you want to just say, you know what, I'm going to bring the v to the negative 2th down to the bottom and make it v to the positive 2th, and now I'm going to add them and call it v to the positive 5th on the bottom. That's fine. I'm okay with that. All over 3u to the negative 1st. And remember, don't rewrite the v cubed because we took care of it. Now, I'm not going to put a square root over all of that because that would be a waste of a line. Instead, I can say that it's the entire quantity to the what power? 1/2. Oh, yeah. Now, again, you have some options. If you still want to do the inside-out approach, what can we do on the inside of the parentheses? We can now combine our u's and possibly our numbers. Or, if you want to jump to the outside and distribute the 1/2 exponent to every factor, you could also do that. Either way is fine. What would you like to do? Yogi Berra said when you get to a fork in the road, take it. And we're at the fork in the road. So we need to take the fork. Inside out, outside in. Do the u's. Okay, let's do the u's. Yeah, okay, it makes sense if we're starting on the inside, stay on the inside. So I'm going to call 2 to the 5th 32. And the 3 is in the bottom. Now 32 thirds, they don't simplify, right? So we'll just leave it as 32 thirds. I already got my v to the negative 5th. So what is 5 minus negative 1? 6. And it goes in the numerator. Okay, now here's another psychological thing that happens to a lot of people. You know you have to subtract, right? 5 minus negative 1. Your brain sometimes says, hey, there's already a negative there. I don't need to subtract because it's already negative. And you'll go 5 minus 1 is 4. And now that's wrong, right? So be careful. Be careful. You're in charge of your brain, not the other way around. U to the 6th. And then all of that is to the 1/2 power. Now, there's really nothing else we could do on the inside. Okay? Everything is pretty much taken care of. One number or two reconcilable numbers, and then one letter of each. So now it's time to distribute the 1/2. And I always come back and do this. I put little numbers on there because it's so easy, again, to, and here are the two mistakes. Students just leave it as 32 and they distribute the 1/2, or they'll put a 16. But that's not what we're doing. We're doing 32 to the 1/2 power. U to the what power? If you could simplify it, that's fine. 6 times 1/2 is 6 halves, or 3. Yeah, you could do that. And then V to the negative 5 halves. And then don't forget the 3 in the bottom. If 32 thirds divided out, then I would go ahead and do that, but it doesn't, so now it's just 3 to the 1/2 power. Is that it? I forgot pep rally schedule. Yep, hey, that was it. That was it. We'll finish this up on Tuesday. The notes in general, worksheet's going to be due on Wednesday. So you have a lot of ability now to complete that worksheet. Have a great weekend. We'll see you at the pep rally.